So as mentioned in the previous video, this section of the video will discuss what are some of the conditions in order to maintain um, momentum to be conserved, or how do you maintain that the initial momentum will be equivalent to the final momentum, or before and after collision. So first of all, let's discuss there are two types of collisions. The first one is called the elastic collision, and then the second one is inelastic collision. So basically the details of these two collisions will be discussed in a few, okay, in the next video, next succeeding videos, and examples of it as well. Right now, let us focus on the second bullet where it says that the momentum will be equal, okay, as long as there is no external forces that is applied. There's no external forces. A example of external force is friction. So what do we mean by this? Okay, so let me just draw an example right here. External force. So forces, for example, after collision, two objects will move away from each other. Okay, so they will move away from each other, or something will happen. So let's say this is a velocity right after collision. So this is what happened right after collision. Okay, right after collision. Now this is made out of a smooth surface where friction is negligible. Okay, negligible. Now this is without. Okay, let's just put the word without friction. Okay. Now here's another scenario where the floor is covered. Let's say the finish of the floor is rough. Okay, so let's say this is rough floor or rug. Okay, so that's the word that I was trying to look for. Rug. It's covered with rug, or it happened on a carpeted area. Rug or carpet. Or just to be exact, okay, so if we have a rough surface, maybe like the pavement, asphalt was not finished smoothly, and definitely without using rocket science here, or not expounding too much on what they think will happen, it's common sense that will tell you that because the surface is rough, the speed or the velocity, because if we consider the direction, okay, the speed of these two objects, okay, the speed of these two objects will reduce because of the surface, the friction. So it will be harder for it to roll down. So this one is with friction. So first one that will affect is friction, the most common one. Most common external force. So this is the external force that will cause it to slow down. Okay, it's friction. Another example is that when you have an uneven floor. So let's say the collision happened on a ramp that is going upward. Let's say first object is moving slower than the second, or the second object is moving slower. Okay, the second object, object 2, is moving slower than object number 1. Object number 1 is moving faster. So what will happen? They will collide. And as they collide, what will happen is that this object will go upward and this one will bounce backward. Okay, bounce backward. This one is falling and it will push each other away. Okay, because of the unevenness of the surface. So let me put uneven. Okay, uneven surface. Not on level surface. Okay, surface. So whatever they want to use as term, okay, they do mean the same, that it's not a straight line. And because if it's not in a straight plane, what will happen is that the effect of gravity will affect the result of the collision. Okay, so the speed of the objects as they hit each other. Same thing on the other side. Let's say this is object 1 and this is object number 2. Of course, Object number 2 will tend to go faster than object number 1. Object number 1 will slow down as it reaches to a certain point, and then eventually will change direction and it will move to the right. That's the reason why you will not have what we call a momentum that is conserved, or conserved momentum, or the momentum before and after collision will not be the same. Okay. Now, of course, earlier in the example, we were provided with the velocity before and after collision on each component. The law of conservation of momentum is applied to determine the motion, so how fast it is moving, or the direction of motion, where it's going before and after collision. So in the next page, we'll be going over elastic, and at the same time, an example of collision where we can apply conservation of momentum to figure out the velocity of an object after its collision.